Here's review assignment number 21. You're given a graph and asked to find the area of this. So if I want to find the area of this, I need to find the points of intersection with my calculator. So I'm going to put both of them in my calculator. So I'm going to, if I have something there, which I do, I'm going to erase that quick. And then I'm going to press tab. I might have to change the window. We'll see. So it's ln x. And the second one is y equals x minus 2. Alright, so I need to expand out a bit because I need to find, I see one point of intersection. Might as well do it. So menu, analyze, intersection, which is 4. So I'm going to find that one. So that's 0.158. So for part 1, part A, I know it's going to go from 0.158. Now I need to find the other one. So to do that, I'm going to take the window and I'm going to expand it out. Kind of see it. Let's do it again. There it is. Okay, so I'm going to go menu, analyze, intersection for the second one, which is over here somewhere. And then where the second one is. So it's 3.146. And then I got to go top, subtract bottom. So I can tell the line, you see the line, compare the curve. So the line's on the bottom. So it's going to be ln x subtract x minus 2. Make sure you use parentheses. Now I already have the graph there. So even though the graph's kind of tiny there, it doesn't really matter. The menu, analyze, I can do it right off here. So I'm going to integrate the bounded area. And then it says, what's the lower bound? You type it in. So you type in 0.158 and then press enter. And then the let's try that again. What just happened? Okay, menu, window. Okay. So let's try it again. So I just did a standard window there. Now let's try again. Menu, analyze, bounded area. And it says the lower bound. So you type in 0.158. And then the upper bound, 3.146. And it's not working. Okay, I'm done. So menu, that's so easy, I'm done. Here, let's do it this way then. So calculus integrate, type it in. So it's from 0.158, 3.146, ln x, subtract, parentheses, try that again, ln x, subtract, parentheses, x minus 2. I get 1.949. Part B, find the volume rotating that around the line y equals -3. I won't show your calculator every time. So -3 is here along the bottom. So we have a big radius. So that's the curve, subtract that. So again, we're going to integrate 0.158 to 3.146. It's pi. We have 2 radii. So pi r squared, pi r squared. So the first big radius, it's ln x, subtract the line -3. When you subtract a negative, it's adding. Then it's x minus 2. So the small radius goes from the line down here. So x minus 2, subtract -3, which is +3. And then type that in your calculator, and you should get 34.198. Part C, write but don't evaluate an expression that can be used to find the volume when R is rotated about the y-axis. So if we're going to rotate it about the y-axis, I have y equals ln x, and I have y equals x minus 2. I need to write this in terms of x equals. So how do I undo a logarithm? Is writing it exponentially. So what's inside the logarithm, and it's e to the exponent y. Here, to get x by itself, just add 2. Those are the two. Then make those equal. Well, I need the y coordinates then of what I looked at. So let's go back to the graph. So now I need the y coordinates. It's there, right? I don't even know what happened right there. Here, the y coordinates are still there. So I see it kind of. The y coordinate, not that one, but the other one. Man, how do I undo the shading part? I'm frustrated. Okay. Maybe. Let me start again. Anyways, if you didn't do what I did, and if you look at the y coordinates there, not the x, the y coordinates, from the points of intersection, you get negative 1.841 and positive 1.146. It's still going to be two circles, and now it's dy and not dx. So if I look at this, it's now looking at it sideways. So we're not looking at it this way, we're looking at it this way. So the big radius from the right to the y-axis is the line. Subtract that. So the line now is y plus 2. Subtract 0. We don't really need it, right? And then the other one going across the little radius here is the curve. Subtract 0. So now the curve is e to the y. Subtract 0, which we don't need. And then type this into your calculator. And you get, that's it. We actually didn't need to put in this. He said just set it up and don't evaluate it. All right, number 1's done. All right, I'm getting off that merry-go-round. Number 2. At an intersection, cars turn left at this rate. The graph shows at that rate. To the nearest whole number, find the number of total cars turning left. So total number, how many, is an integration question. So I'm going to integrate from what it tells me, from 0 to 18, and I'm going to integrate that function. Type in, when you type in L at t, that means in your calculator, you actually have to type in 60 square root of t sine squared, and so on, t over 3. They're testing your skills. Let's see. Can you actually type it in correctly? It's kind of sad that they test your skills like this, to be honest. You should just be able to not have to do that. Menu algebra or menu calculus, integrate from 0 to 18. And then can you type it in correctly? See, I don't think it should be tested quite like this. So it's 60. The square root of t times parentheses sine t over 3, then square it, just the sine part. See how they're testing it? I don't like that. And then dt. And you get the answer to the whole number, 1,658. Good practice, right? You got to do it. Sometimes they do that to you. Part B. Traffic engineers will consider restrictions when that rate is bigger than 150. Find all values where that rate is bigger than 150. So the average value so we take the rate and we see when is this what greater than or equal to 150. Let me show you. We're going to go menu, algebra, solve. We're going to type in 60, the square root of t, times sine, no, go back, times parentheses, sine t over 3, move the cursor, again, square it, now it's right. And then less than or equal to, right? Or greater than or equal to. Go control, equals, and then you have greater than or equal to, and it's 150. Then we're going to go comma t, and then let it do its thing. Man. So you have to solve it. I'm going to let it go. What silly calculator skills. If you do solve this with your calculator, the two answers, it's from 12.428 to 16.122. We could also graph it and see where it's above 152. So here's another way. Now that I'm thinking through it, get rid of this stuff. All right, this is here. So I'm going to type it in again with x. So 60, the square root of x times parentheses sine x divided by 3, and that's squared. We're going from 0 to 18. So menu, window. We're going to go from 0 to 18, and then really we want to know where it crosses at 150, when it's bigger than 150. So that's fine, because what I'm going to do is just go 150, and then I'm going to see where those two lines intersect. So I'm going to go analyze an intersection, and then so the first one is at 12.42, right? That's what I said, right? That one. And then if you do intersection on the right side where the two intersect, you get the other one. Yay. All right. Next, it says find the average value. So I'm going to integrate for those values, 12.428 to 16.122. And then subtract those two numbers. And then put that in your calculator. Average value. And you get 199.426 cars per hour. So on average, that's how many cars are turning left over that interval. Almost 200. Part C. Traffic engineers will install a signal if there's any 2-hour time interval during which the product of the total number of cars turning left and the total number of oncoming cars traveling straight through the intersection is greater than 200,000. In every 2-hour time interval, 500 oncoming cars travel straight through the intersection. Does this intersection require a traffic signal? I'm going to tell you not to do it. Number 3. I'm in that mood. All right. I like this one. So here we have a graph and we're doing calculus. I can do this, right? You can do this. So we have, remember, you see this all the time where something's defined by an integration. All right, so find these things right here. So let's do this. These 3 and 4, let's focus and have energy to do those. So g at x is equal to the integration of 0 to x of f at t dt. So that means the derivative is just f at x, and the second derivative is the first derivative, as you do the derivative to both sides. So when you're asked to find g at 4, you use the top one, and you find the area from 0 to 4. So if I find the area from 0 to 4, I have one area below. That's the triangle. That's negative because it's below. And then I have a trapezoid that's positive. So the height is 2, and the two bases are 3 and 1 that we add. And there it is. The derivative at 4, I look at the graph at 4 and know what's the function value at 4? That answer is 0. And then for the second derivative at 4, I'm looking at the derivative at 4, which is the slope off the graph. So what's the slope here? Down how many? So it's down from 2 to, so it's down 4 and over 2. Negative 2 is the slope. All right, part B. It says, is there a maximum or minimum for G, or neither at 1? So we have to look at this first. That's just f at x. If we make it equal to 0, that means we're making f at x equal to 0. Where are the x-intercepts? Drawing a number line. So that's at negative 4, at negative 1, at positive 1, and at 4. And it goes negative, positive, negative, positive, negative. Okay, and then it says what? At what number? At 1. So at 1 we have a minimum. And we justified it. It goes down then up. Part C. Suppose that f is defined for all the numbers and is periodic with a period length of 5. The graph above shows 2 periods. Given that g at 5 equals 2 and g at 10, write an expression for the line tangent to the graph there at x equals 108. So when x equals 108, I'm just looking at the answer if it's worth our time. No. Number 4. We're not trying to be perfect, right? We're just trying to pass. All right, how about off a table? Do you know how to do calculus off a table? First is average acceleration in terms of that. So to find the average acceleration from 0 to 80. So what I'm given is the velocity. So the average one would just be the AROC, right? From 0 to 80, because that's the derivative with this table. So that would be 80 take away 0. That's the bottom. And then the top would be the y values, which is 49 take away 5. And that would be in feet per second squared. That would be the average value. the average acceleration, which is the slope over that. What's the meaning of integrating in terms, and then use a midpoint Riemann sum to do it? So if you're integrating from 10 to 70, that means from 10 seconds to 70 seconds, how much feet have you covered? So that's the interpretation of it. And then a midpoint Riemann sum. We would go 70 take away 10 divided by 3. So that's 60 divided by 3. That's 20. So if I'm integrating from 10 to 70, a midpoint, the width of each one is 20. So from 0 to 20, the mid height is 14, plus the next mid height would be 29, 40, and 47. And then we would write down from t equals 10 seconds to t equals 70 seconds. That's how many feet were covered. So that's how much it traveled. That's the distance that it traveled. Part C. Rocket B, different rocket, has an acceleration at time t equals 0 seconds. The initial height is 0 and the initial velocity is 2. Which of the two rockets is traveling faster at t equals 80? And explain that. So the velocity is this. And then they say the initial velocity, right? And then compare that to the velocity at 80, which is 49. So compare this answer to that answer. What does it say? Rocket B is faster. All right, turn the page. That says Rocket B is faster. All right. Some questions, if it's not worth our headache, I'm just going to avoid. And these are all questions from College Board from way back when. Like this is from 2006. All right. It says use this and draw a slope field. So to draw a slope field at each point, we need y and x. So first of all, when y is -1, it's 0. So that's helpful to know. That's here and here. Oh, when x is 0, it's empty. So don't put anything here. These are empty. This is 1. Here at -2 and 0, that's -0.5. Here at -1 and 0, that's -1. That's empty. At +1 and 0, that's 1. At 2 and 0, that's 1/2. All right, a couple more here. 1, 1 gives me 2. That's empty. -1, 1 gives me -2. All right, so you've drawn that. So I did the slope field. Find the particular solution with the initial condition of -1, 1. All right, I'm just going to do it right here on the page. Is that all right? I'll do it here. So, can you solve a Diffie-Q? Can you separate the variables? So I'm going to multiply by dx and divide. So if you separate it, this is what it's going to look like. And then integrate this. These are both going to be logarithms. You can plug in the point, which is -1 and 1. So if I plug in 1 for y, you get 2. If I plug in -1, it's just 1. Now ln 1 is 0. So c is just equal to ln 2. So this is what I have so far. And then to get y by itself, and then subtract 1. And you have the answer. You could simplify this differently. Adding means you could multiply it. And e and ln cross out, and e and ln cross out, so it's just really 2x minus 1. All right, part number 6, last one. I might say not to do it. What the hey. G at x, e to the ax plus f at x. Find the derivative. So the derivative of this is you copy and the hook. The derivative of ax is just a. And then the derivative of f at x. There's the derivative. The derivative at 0 would be, you plug in 0, e to the 0 is 1, so you have a. F prime at 0 is negative 4, so you get a minus 4. The second derivative, here, we copy again, and then again there's the hook, and then the second derivative. So this is really a squared e to the ax plus the second derivative. So if I want to know the second derivative of 0, plug in 0 for x again. That just gives me a squared. And then the derivative, second derivative of 0 is 3. So it's a squared plus 3. B, let's see if I want to do this one. I know what your answer is. What the hey. All right, so the derivative here for cosine is negative sine with a hook. Oh, it's a product rule. So the derivative, we can do the derivative first times the second plus the second. The derivative of the first time, and then the derivative of the second times the first. What have I gotten myself into? So the product rule. And then when x equals 0. So when x equals 0, when I plug in 0 for x, you get cosine 0, which is 1, times f at 0, which is 2. So it's 1 times 2. And then the slope, you plug in 0. Sine 0 is 0, so that's going to be done. Plug in 0, and you get 1. The derivative at 0 is negative 4, so it's 1 times negative 4. So the equation of the tangent line is negative 4, x minus 0 plus 2. Is that it? That's it. Mr. G Math over and out. I'm proud of you. This is a tough one. It's all good. Till next time.